Hello. Hello. Can you hear me?
Hello?
Yeah, can you hear me?
Yes, I can hear you.
Okay, so let's
How are
go.
you?
I will try to show you this process. How we can easily use the single image to make the chlorophyll concentration mapping. Okay, so let's go. So just I simply share my screen. So now can you see my screen? Is it visible?
Yeah, it's trying to appear.
Yes, so let me open. And I have to use the network. It's here. Okay, so in this time here you can see. Can you see my Discord? Yeah. Can you see?
Yeah, I can see a screen.
Okay. So in this time, we have to use the single date image without taking the median image collection. You can see, I just
Mhm.
simply remove this type of things in this time. It's not need. In this time, we are just take the single image collection. Okay. And how it will be work. So here you can see, uh, yeah, just I show you that. Here you can see this is our lake of bacteria. And in this time, it just show this result only for these tiles. Okay. In this time, we're going to check the result from here. You can see we get the result only for these tiles, only for this lake. So
Mhm.
in this time, suppose I just simply try to remove the cliff function, then I can get the full tiles. I just simply try to show you the full tiles first, then try to explain how it will work. Okay, so here you can see it loaded a tiles about that. This type of tiles you can get. Okay, so in this time, this is the tiles and it's a single image. Okay, how I can get this image? You can easily get the single image, all of single image collection. Here you can see we can get the 209 image collection in this time. Year of 2019, 1st January, less than 90% cloud cover. You can find out that total 209 images. Suppose I just choose only for the suppose less than 10% cloud cover. So now it show me that how much image is available which are the less than 10%. In this time we can get this type of things here. You can say I can get that less than 73 images. Okay, for this study area. Okay. So basically in this
Mhm.
time, and also you can see about their list about all of images. Here you can see the 73 images. Here you can get the, it will be start from the 0 and up to 72. All of this means I can get from here. You can see the serial wise we can get. And from here you can easily choose any one image. Suppose I want to choose this image. Okay. So how I can do that? You are just simply copy this image ID. Here you can see it also provide the image ID. So just I try to open my screen bigger. So here you can see it also show the image ID. Okay. So this is the image ID. Basically, you can see about the acquisition time 2019, 2nd January. Okay. Just I simply copy this image ID from here. And then further, I just paste here. Okay. Just I paste here. Remove the previous one. I simply paste in here. So now I can get this single image. Okay. Between this time and click to the run. So now I can get this result based on this single image. Okay, so let me check about that. And it's the problem is that in this time, single tiles is not enough to cover the full study area. Okay, you can see we can get only for this study area. it's not fully cover my study area, because one tiles or one single image is not enough for this whole lake. Okay, one tiles is not enough. But when you want to work for the single image, then we can get this type of result, not for whole region, not for whole lake. Basically, this is our study area. Okay, but this is our full study area. But when I want to work for that single image is not capable to fill up the full study area. Okay, suppose in this time when I want to choose this study area, it just fill up only for this region. Only for this region I can get this result. Okay, so let me try another image. Suppose just I try to put the another image. Suppose this image I want to choose. So for that I just simply copy this ID and then change it in here. Paste. Okay, so now it show the result for this time, and you can see it also not fill up the full boundary, because one tiles is not enough for this whole study area. In this time we can get this region, you can see. Okay, in this time it's my study area, it also fill up this type of region, so that's why it also considered as a tiles in here. Okay, so in this time for this region it's our big study area, so that's why in this time we are take the median composite. Suppose it also okay. Suppose when you want to work for any small area, suppose my study area is only for this lake. Suppose this is my study area. Okay, so this water body, it's my study area. Okay, so then we are easily cover using the one single tiles, because this study area is not much big. Suppose let me show you that process. Suppose I just click to the run. So now I can get all of the image collection from here. And I simply choose the image. Suppose I just choose the image from here and try to open a image from feature. Suppose I try to use this single image. Just simply click and copy this ID from here. So it's a single image, okay? Single tiles or single image acquisition time, not any median or other things. So just I paste here. Paste. And now click to run. In this time I can get this result only for this study area. So now let's check what happened. Okay, now you can see the result from here. You can see this lake is almost fill up the full boundary, almost fill up the full water body, but some reason is not fill up. Okay, so for that, if you want, you can also increase the cloud cover level. Suppose I just put here that or try to check the another image. Suppose click on here and try to check the another image. Suppose just click on the feature and try to check the about this image. So copy this ID and then change the image ID from here. And paste here. So click to the run. In this way, we can get this result only for this study area. Okay, so in this time we are also get the same result also in here. You can see it also not fill up the full region. Okay, so this tile is fill up only for this portion, but other portion is not fill up. Okay, so basically this is the problem. Okay, when you want to work with for the big lake, then one tiles is not enough. For that region, we have to create the suppose median. Suppose total 4 tiles. We median mosaic all of those tiles and create a image. But when you want to work with the single image, then you can get this type of result. It's not fully fill up your study area. So in this time, you can see it not fill up this part, but other part is also fill up. But this part is not fill up because there is no image in this time. It's not covered. But you can see here, when I use here the median, just I use here the median, mainly in this time, it creates the median composite and clip with your study area. Suppose it's a ROI. Okay. In this time, you can see this result, it fill up our whole water body and we can get the result more better, because in this time we create the median composite and it fully fill up our study area. Here you can see. Okay, you can see now it's fill up our study area. Okay, we can get the full cover map. It's fully fill up our study area or lake. But when I want to work with for the single image, suppose only for the one image I just consider, and then without median function I just work with that, then it not fully fill up my study area. It show the half image, or it not fully fill up my study area. You can see. Yes, you can get the result only for this. So this is the problem. Okay, when you want to work with the big region or big study area or big lake, then you must make the median composite. Or when you want to show only for the single tiles, then it not fully fill up our study area. We can get only for this part, some part are the missing. Okay, so I hope you can got this idea. Okay, so any questions?
I understand.
Yeah. So basically, this is the problem about that. You can also talk about your supervisor about that. So you can say him, it's not fully fill up my study area. Suppose one image is not fully fill up. So that's why all of image I need to create the median composite and then visualize this result. Because in this time, one image is not fully fill up your study area. So that's why we have to create the median composite. Mainly median composite is the created from the all of images. Suppose here you can see in this time, here I can find out total 7 images. When I use at the median, then this total 7 images create this median composite. At the same time, it create the merge and create the same images median composite. So that's why it fully fill up our study area and we can easily get this result. But when I use at the single image, then it not fill up our fully study area. Some reason is missing, is not showing. And you can see without the image collection, mainly without the image collection, in this time here you can see, in this time you can see this part we are not applying any kind of median. Okay, in this time we are considering all of images for creating this time series chart. We are using the all of images. Okay, so in this time we are not put any kinds of other median composite that we are not consider. In this time we are consider all of images, and further we are create this time series chart about that. Okay, so here you can see it's there is no any kinds of median function or other things. We are just take all of image collection, and further this image collection we are used to create the time series chart of chlorophyll. But when we want to visualize our result, in this time our study area is much big, so that's why one tiles is not enough for the full cover of our lake. So that's why we create the median composite and visualize our result.
Okay.
Okay. So you also think about that, what Professor you said. Okay. So basically, when you want to work with a single image, it's very easy. Just you can simply click on here and you can see the feature and you can get the total 7 images. So simply copy, you can see it's a one single image. Just copy this ID and paste here. Okay, then it will be work only for the single image. Or when you want to work with the median composites, just simply use the median and clip, then it create the median composite and show the result. Okay. So you also try to check this code. I already send you this code. And basically this type of problem we face when you want to work with for the big region, because one tiles is not enough for the big region. So that's why we must need to use at the median composite to create the image collection and then get the output from here.
Okay, thank you. What about, can this code be used to like assess other late, like if I change the ROI for a different region?
Yeah. So
can this
for
code be
that,
used?
okay, when you want to work for the different region, It's very easy. So for the single image, suppose for the when you want to change the result for the other region for the single image, then you have to change it. When you want to work for the single image, then you have to change this ID. Suppose in this time, I just simply remove my ROI. Suppose this is my ROI, simply remove, and I want to take the new ROI. So for that, suppose in this time my ROI is that another lake. I want to choose the another lake.
Lake
Suppose
Lake Tao in China. We can look for Lake
lake
Tao. Lake Tao.
Tau.
Tahoe Lake, yeah. Go go right, go right, go right. You see it. Maybe you can minimize the map so that I see. Just minimize it. Minimize the way. Yep, 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 yep. You can scroll up.
Or you can take the spelling. I also write in here. What's the name?
TAHU.
T A
TAIHU. TAIHU. TAI. Yup. Star Lake.
Is it?
No, no, that's not it. If you can minimize the map, I will show you. Go, go.
Okay, where is it?
Okay. So you find it around Suzhou. It is in the Suzhou region. Down, 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 down. Okay, so you can expand the map now. You will find different there. Just expand the
Here.
expand the map. Yeah, just enlarging the map. You'll find it. It will surface. Yeah, go ahead. Go ahead. Expand it again.
Here, yeah.
Yeah, around there. You can find it. But you can use you can use any link. Okay, what about can you go left a bit? Left your left hand side. Let me okay. Okay, we can use this other link. Yeah. Right to Kunming there. It's up there. It's up there to S5. No, you S5 between S5. Okay, right there. We can use that link.
Is it?
I don't know. Let's just use that. Let's just use that.
Okay, we can use it. You can also try to check later. So for that, you are just click on rectangle again. You can see I already removed the previous ROI. Okay, click on here, then it will be removed. Then take the new ROI. Click on here. You can see it show the geometry. So you can simply take the geometry. Suppose it's your leg. You can simply take it. And further, you are just change the name as the ROI. So ROI. In this time here, you can see if you want to use at the median, so it's very easy. They not need to change anything. Suppose just use at the median and also click with your study area ROI. And further, I simply uncheck it and click the run. In this time, I can get the median composite result for this study area.
Okay.
And in this time here, you can see it's another problem. It shows the 0 bands. Mainly in this time, there is no image which is less than 10% cloud cover. So that's why it shows the 0 bands. In this time, I need to increase this cloud cover level. I put the 90% cloud. Now try to check again. In this time, we can get it. So we try to add here, suppose 80%. Okay, so in this time, let me check.
Maybe we can choose another water body because this is a reservoir. I don't know. Maybe that's what we can
Okay,
choose
so that's why,
a
yeah.
natural water.
Yeah. So that's why it's take the problem. So I remove the ROI.
Yeah, like we can choose a natural water. And then lake in China, and then like B lake.
So suppose we try to add this lake. Suppose this is the lake. We try to check that. Okay, so for that, I simply click on here, and then we just click to ROI, and then put here this ROI, and now click the run. So now, okay, so now it's working. See, so we can get this type of result, and in this time it worked well because I use here the median, and we can get this type of result when you want to just click on here, and it's increasing the stressing level. That was 98%. Then we also get the more better result. So just apply. So now we also get the more better result. You can see this time. And further, you can also download this tip format from here. Or any, like, you can simply try to choose the study area. Suppose I just try to show you from it's Bangladesh, one region. So this is the one kind of lake. So just I simply take this ROI. I just quickly remove the previous one ROI and take the new geometry and draw my study area. So it's my study area. Okay. And I put this name, it's a ROI, and then click the run. So now I can see we can easily get this result, and also uncheck this type of satellite image. It's a satellite image. Then you can see it's our chlorophyll, it's our water body marks, and it's our satellite image. So this is our satellite image. Okay. So from this satellite image, we can get the water body. It's the water body, and it's our chlorophyll result. So in this time, I just check this. You can get only for the chlorophyll. So now we can easily get this chlorophyll map about this lake. What is the condition about the chlorophyll, and we can download the image from here. Okay, and in this time it creates the median composite. But when you can see when I want to work for the single image, so for that what can I do for the single image? For the single image, you have to change it. You can simply go to the console tab, and you can get the image collection. In this time, you can see it's not show any image collection. For doing these things, we are just commenting this median and also commenting this clip. So in this time, it show me all of images, how much images available for my study area. So just I click on here, you can see I can get 12 images. So from the 12 images, I want to work for the one single image. So just I simply click on here and copy this ID. Simply copy this ID. I copy and then paste in here. Simply copy and paste. Okay. So now it worked for the single image. So now we try to check the result for the single image for our study area. You can see in this time it not fill up our whole study area. You can see it loaded. So in this time you can see. Okay, so in this time it's a small area, so that's why it's also worked very well. You can see we can get the this is the full study area. It fill up. Okay, you can see it loaded for the full tiles. Okay, it loaded for the full tiles, and it cover all of those water body in this satellite imagery. Okay, and here you can see, if you want, you can also use here the clip function. So just use here the clip with your ROI. So mainly put here the ROI. So now we can get the result only for this study area. Okay, which I selected. This time we can get the result only for the selected study area. In this time it's a small area, so that's why it's easily covered for the single tiles. And in this time we can get this result for this single tile image. So, a single time image or single image also you can get from. Okay, so basically this is the process about that for using the single image. And single image is mainly work very better well in your small region. But when you want to work for the big region, then it's not fill up the full study area. Okay, so that's why it's another problem. So it's, you can also check about that. Okay, and further if you need any help, I also guide you, no problem. Okay.
Okay. So for this code, what the mentor we use for this code to develop this code, like the algorithm, which algorithm we're using here?
NDCI. Okay, so basically I already sent you a paper, NDCI.
On the NDCI, there is nothing combined with it, right?
Yeah. So in NDCI mainly it's a normalized difference chlorophyll index. Okay.
Okay.
So this is the things about that. You can see we are use these things for the identify the chlorophyll index, and it is a novel model for remote estimation of chlorophyll A concentration in turbidity productive waters. Okay. So in this time we are applying this formula for NDCI, and then try to find out the chlorophyll from the water body. Okay. So you also try to read this paper, then you also get the more information, basically NDCI, how it will work, and all of those things you can easily get from here. Okay.
Okay.
And then already a lot of paper is already published using the NDCI method. Okay, mainly chlorophyll using the NDCI. So
yes, I was reading a lot of them, but then they have different combination. Like with the NDCI, they have other algorithm that they combine with it to do the analysis.
Yeah.
So I was just thinking whether we are using more than one algorithm in the coding.
Yes. So if you find any other algorithm, you can also try to use it. But for that, we need the ground truth data. It's called the linear equation. Okay. So when you want to make the linear equation, you must need the ground truth data. And for using the ground truth data, we have to create the linear equation. Suppose you can see that a lot of equation. Suppose I show you the one, suppose PIS monitoring using remote sensing. Not only PS, and there are the lot of, we can get the linear equation for using the different types of monitoring of the water. So you can see, you also check the paper. Basically in this time they are use the linear equation to identify for the different types of water quality parameters. Here you can see this type of parameter. Yeah. So here you can see, yeah, you can see there's a lot of equation about that. You can see this is the equation for chlorophyll A concentration, but this equation is not for your study area. It will be changed based on your ground sample. You can see they are also compared the ground truth data and also put at the 71% accuracy about that. Also you can see the pH or turbidity. So this type of things you can easily do, but for this time you have to need the ground sample for creating the linear equation.
Okay.
Okay. You also read this paper also. Okay, because if you manage, you can see they take the training sample for a study area. Okay, and further there you use it and also try to find out the linear equation, and they also create this type of map for the turbidity, chlorophyll, or other things they are used easily. So you also try to check it, but in the NDCI in this time it's called the normalized difference chlorophyll index. We are not use any kinds of equation. We are just apply the index formula. Okay, NDCI formula, then we can easily get this result.
Okay.
So you also try to check and also read this type of paper. Also read the NDCI. Okay, and also talk with your supervisor. Then further, if he put any kind of guideline or any put anything, then you can also let me know. I also try to for doing this type of things. No problem. Okay.
Okay. Okay.
Okay.
Thank you so
Okay.
much.
Okay. Thank you. Have a good night. Okay.
Okay.
Okay. Bye.
Bye-bye.